now.
Okay, thank you. Thank you, Samuel. Good evening once again. Thank you for having me. It's an honor to be here. Um, okay, so I guess I'll just dive right in. Like someone has introduced, my name is Mordecai Godwin. I am currently a full stack engineer at Axon Insurance PLC here in Lagos, Nigeria. Although I'm full stack, I major in backend development and I write the .NET stack. I'm also aware that your classes has been conducted using the main stack, that's Node.js and what have you. That's beautiful, but I guess I can manage here this evening. All right, so don't mind something when you said the best of the best. I'm still learning, like everyone here actually. So let's feel free to connect and ask questions or if anything. So this session is not tailored to coding directly, but if you have any question across anything at all, please feel free to ask. Okay, so I'll be discussing an interesting topic this evening, although it will be short. So I believe the rest of the time will be useful to have meaningful conversations and ask questions. So please confirm you can hear me. I'll be asking for such confirmation once again. Thank you. Thank you. Okay. 1 minute. I'm trying to share my screen. I have a tiny slide. Okay. Now, kindly confirm you can also see my screen. Okay, thank you. It might be black. Just about sharing the slide. Let's present this stuff again. Okay. No. Muted. Present. Okay. Sorry. Okay. I guess I've been able to do it now. Sorry, guys. Presentation is not my strong point. So I missed the flickering. All right. Okay, so the topic this evening, as you can see, don't mind the fancy word or the fancy phrase, the art of debugging. But actually, debugging is an art that you learn over time, that you get used to, that you get better at. So, and this is a very useful skill that, irrespective of what you do, back and front end, even if you are an embedded system engineer, whatever you're doing. In fact, it goes beyond coding. It goes even in everything you do in life. Anywhere you find a problem, the 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 process of fixing that problem in code is called debugging. Can be used with other terminologies in other industries, but it's basically the same. So some of us here, I don't know if does anyone here has a science background or a computer science background to be specific, either in school or you're familiar with it, or you have an uncle that taught you one or two things in computer, how to fix stuff. Or some of us here, like me, when I was young, you like removing the screws of your DVD and checking what exactly is inside, what's making the disc spin. I bet people like that here recently. Okay. All right. Let's go ahead. Okay. So the art of debugging. Um, as an introduction, debugging is an essential skill for any programmer. It involves identifying, analyzing, and fixing errors in code. Well, studies indicate that developers spend approximately 50% or more of the time. I think I'm on the upper side of this percentage on debugging. So we spend 50% or more of our time debugging code. Mastering debugging techniques not only improves your code quality, but also enhances your problem-solving skills, ultimately reducing development time and cost. Most of the time, the key differences between a junior developer and a mid-level developer is oftentimes their ability to objectively look at the code base and find issues, or look at a problem and fix it. Most of the time, it's for most of the basic tasks, right, is the same syntax that a junior dev is using to write code that the mid-level developer is using to write code. Usually even the same for a senior dev, or most the significant difference between a senior dev is usually their leadership roles beyond writing actual code. They do different stuff, they conduct code review and what have you. So what makes a difference, how you measure your growth is how quickly and how efficiently you can solve problems, or you can um, fix bugs. Right? So I just want to touch on a few things here on how you can go about debugging your code. Okay, so first off, let's quickly brush through some of the types of bugs we have or we face on a daily basis. This is just the common ones. There are a whole lot of different classifications of bugs, but these guys here build the foundation for you on how to fix these issues when you face them. Um, okay, so once again, I want to apologize in advance. I know learning is usually interesting with a lot of graphics and not just text. I've had this slide before, but it was tailored for .NET developing. So when I learned that we use JavaScript here, I had to just pull them off. But I still have about one screenshot there. So you won't be seeing a lot of graphics or codes, but I'll do my best to explain what I mean by this, by the text or you see on the screen. So please, if you have any question at any point in time, I'd rather not wait till the end. Just raise your hand, and if I do not see your hand, I'm sure Samson will call my attention to it. Okay, common types of bugs. Basically, the first one and the most common one is syntax error. These are usually issues with the language rules that you're using to code. The errors will prevent your code from compiling successfully. That's often how the red lines that your ID will draw under a code base, that particular error, telling you that this code will not compile if you do not fix this. That such errors are called syntax error. It's basically the rules that guide the code base. So I know in JavaScript JavaScript is not strongly typed, right? So you can set a variable to have a number in line 10, and in line 25 you can override it with a string or an object. But in C Sharp, or even when you now start using TypeScript, it's going to prevent you from doing stuff like this. So if you declare a variable as an integer before, you cannot assign any other data type to that variable. So that code will not allow you to run it first, and then it breaks before it tells you something is wrong. It's going to underline it immediately. So those are syntax error. So the next type of error is so the next type of error is um, runtime errors. They typically occur after the project compiles successfully. but then it will fail to run the code or to execute the command you have given it to do. So this is when you've written your code, everything seems fine, but then you run it, and before the code can display the output you wanted, the error occurs, and you see a lot of red stuff in your console, or sometimes if you're using an IDE that can set breakpoints or that can throw errors, then it returns you back to the code and tell you something is wrong. So then, logical errors is very similar to the runtime errors. However, in this case, the most of it, actually all of the times, the IDE will not be able to help you in this instance, because logical errors deals with wrong outputs. The code runs perfectly, and you're just getting the wrong output. So imagine you are doing a simple arithmetic, saying number one plus number two, a variable now. Then you are logging it in the console, and you expect that you expected to see 4 in the console, hoping that number one will carry 2 and number 2 will carry another value 2, then have a 4 as the output. But then you're seeing 3, or you're seeing 5, or you're seeing 10. So that's an example of a logical error. Your code is running, but you're not getting the desired output. Okay, like I said here, this sounds simple, but usually can be sometimes hard to fix. So next, performance bugs. I'm not sure if, you guys will be facing stuff like this yet, but it's good to know, right? No knowledge is wasted. These issues are typically the ones that will slow down your application, that will slow the execution or consume excessive resources. So maybe consume your laptop or your server's RAM or CPU or storage space. This kind of bugs, they are performance, they are categorized as performance bugs. So the last but not the least in these common types is security. So these are basically security bugs, vulnerabilities that a third-party personnel can exploit to gain an unauthorized access to your systems. So, for example, this things is common. You hear that they hacked this company this day, they hacked another company tomorrow, and all of that. So these bugs can be categorized as security bugs. So once you have a knowledge over a high level category of bugs and you face one, you will know where to look. You will know how to tackle it, right? So okay, moving on. All right. So the common reasons or sources of bugs. So we know the different categories of bugs that there can be. So let's quickly look at some of the quick reasons that can cause this. First is in human error. This is the first. You mistakenly type something that you're not supposed to type, then um, it results to an error. Let me quickly share something in this human error. So there's a project I'm currently working on. Um, it's for the Nigerian Insurance Scheme Association. I think NHIS. I forgot the full name now. NHIS, NHIE. So that they are basically the ones dealing with the insurance for civil servants. They are working on a software to make it public, such that the whole of Nigerians can access the subsidized insurance cover. So we finished the MVP of the application, and before deployment, the government decided to hire KPMG. I don't know if you're aware of, if anybody knows KPMG here. There is a security company to come and conduct a security test on the application before it goes public. Long story short, something interesting was found, a bug, so to say. For a scheme that a user was supposed to pay a sum of 66,000 naira for, Those guys, I don't know how they did it. They were able to pay 150 naira, 150 naira. So that is a huge, huge security bug. So they had to, report it and all that, and we had to work on it. Long story short, it was a human error. It was not the code. It was not because something else happened. It was just the fact that the way the system was built initially was not the correct way, and that needed to be fixed. So when you come across a bug, don't always exclude yourself as the cause, so that it will help you have a broader approach to the issue. A next common reason is incomplete requirements. This usually comes up from when the project's requirement is not properly done. So before you start a project, um, for example, if you want to build a house, the very, very first thing is will not to just start laying your foundation and start laying bricks. You need someone to call an architect to sit down and lay out the structure on paper before you start doing the actual work. That is the exact thing that happens with software development. So if the project is not properly outlined from the beginning, it can introduce bugs, right? And let me also say something here because it's something that's affected me over and over again. Do not at the for how do I say this? Do not, because of the fact that you want to fully capture the requirement of the project, now stay in one point. You are gathering information. You keep gathering, gathering, and gathering, and you never end up doing anything. Is not going to pay you at the end of the day. So you gather the reasonable information you can. Every project has the luxury of revisiting it and refining the process and continuing. But at the same time, do not just jump into projects without having a clue what exactly you want to achieve. Okay, I think I need to go faster. Code complexity. So this can also introduce bugs. The bigger the code base, or the bigger the requirement, or the bigger the feature that you want to develop, the bigger the risk of having bugs. Another reason is lack of adequate testing. So this is also something that is very, very, very common in Nigeria. I don't know about other countries yet, because I've not been to any other country yet. But a lot of Nigerian companies, they do not place enough emphasis on testing. Why? Because basically they think testing takes time. I mean, before you sit down and start writing unit tests, writing integration tests, before actually writing the feature, they think it wastes time. But if God helps you, if you run into a difficult bug and you end up spending more time to fix that bug. So if you have adequate testing in place, it will help you avert future issues. So let me share a practical example. Um, when I first joined AXA Mansard, I was given a project to refactor because number one, the projects were using old versions of the technology, old versions of C# and .NET. But in trying to understand the code base, or while I was trying to refactor things, because there were no form of unit test or any form of automated testing, if I change something, let's say on the homepage, just for an example now, I might come back to realize 3 days later that something has started breaking in the product page, and then find out that it is what I refactored in the initial page that caused that break. But if there was unit testing in place, anytime you make changes to your code, you can always run the entire automated test over and over again. And anything that needs to fail will fail immediately while you're still in code. So it is not in production you will be seeing issues. Okay, next thing, concurrency issues. This usually comes from when your application is doing a lot of things at once. So usually these high level languages have the ability to run things asynchronously. where one thing can be running, and instead of delaying the system and delaying the resources until that process finish, you can free it to do some other things. So if these data depend on each other to operate, it can cause bugs, right? So it's worth to know that whenever you're dealing with asynchronous operations, just be careful. And whenever you have bugs related to operations like that, look at it over and over again. Next in hardware and environmental factors. This one's pretty straightforward. Um, this is when your system simply does not have, or the server does not have enough capacity to run a project, right? So every project has its requirements. So a simple to-do application can obviously run with let's say a 4 gig or 2 gig, or even 2 gig RAM memory, right? That's still considerably slow. But for a project like, let's say you're running multiple reports that you need to send every day in the background, while at least 500,000 or a million users are using the application concurrently, 2 gig cannot will not be sufficient for you. If you provision that kind of software in a server that just have 2 or 4 gig RAM memory, it will run into issues. You have a lot of bugs. You think it's just code, but you need to just understand that hardware can also be a factor. Then last thing, code duplication and poor maintenance. Okay, that basically just says write your code in such a way that it can be easily maintained. Do not have too many dependencies that one code is depending on each other to run. At the end of the day, that will cause the kind of issue I shared just now, where when you change something in class A or file A, break something in another file entirely. All right, moving on. Please confirm you can still hear me. Are you still with me? I hope I'm not boring you too much. Okay. Yeah, this is just on a lighter note. Philip Ford says debugging is like being the detective in a crime movie where you are also the murderer. In short, you are looking for the crime where you committed the sin in the first place. So it can be an interesting cycle. Sometimes it may not be. Don't beat up yourself too much. All right, so let's look at 4 common approach to actually now conduct the debugging. So we have brute force method, backtracking, cost elimination, program slicing, among a lot. All right, basically, brute force is the most common technique. This is, and is also the least efficient. In this approach, the program is filled with print statements to display intermediate values. In your case, that becomes a log. So you log a lot of variable, just log everything and anything you can log, hoping that some of these outputs will help you identify the source of the error. This method becomes more systematic with the use of a symbolic debugger, also known as a source code debugger. Okay, this is just a fancy way of referring to your IDE. Usually, most of the IDEs now come equipped with the source code debugger where you can set breakpoints, you can step into, step over, and do all of those nice things. So this allows you to check variables directly instead of having to log. So additionally, breakpoints and watch points, that's what I just mentioned, can be easily set to monitor the values of variables without much effort. So yeah, brute force is that simple. It's also one of the first techniques that comes in handy whenever you have a bug, most of the times. Although it works fast for some issues, but for some other issues, it can be time wasting. So this is just an example or a flow of how it works. So when a bug is reported, you come to the code, you check. If you do not see the problem, you set breakpoints, then you step over code from start to finish. That's something about brute force. Oftentimes, it requires to start from the beginning to the end before you can find the issue. And sometimes you might have to do that over and over again. So that's basically the cycle that's in this diagram. So if you see anything weird, you step over the code, continue to check, And if you cannot see the cause of the weirdness, I mean, you continue to provide different input values to see if you can reproduce the problem. Then you try to fix the weird thing you saw. It might not be the cause, but you saw something weird. You fix it, and if it's the fix for the bulb, for the initial bulb, then you're done. But if it's not, you have to start again and start logging data, right? Sorry, this code is in C sharp, but it's quite similar to JavaScript. Line 9 is a typical function in JavaScript. Line 15 is the usual for loops and all of that. But look at this algorithm now, trying to find the solution. A typical brute force approach would be to put console logs. In C sharp, we have console.writeLine. You can see line 12, 13, line 20, 21, line 26, and line 33. So, and this function takes in an array of numbers. So imagine you have, let's say, the entry point of this function is providing an array of 50 numbers. Imagine how many logs you're going to find in your console. So that this method sometimes is inefficient, right? But it is there. The other method, backtracking, and this method it basically starts from the points where the error was identified, and then you work your way backwards in the source code until the root of that error is found. Unfortunately, this can be very useful, but when the code base is big, the bigger the code base, the potential pathways of tracing back that there is. So, which can make this approach difficult sometimes. But if it's something you can work with, there is no lot of functions calling each other and each other and each other, rippling down the code base. You can easily use this to trace it on time. And the call stack is a very useful tool when using this approach. Okay, so I'd like to ask here, is anyone here familiar with what we call the call stack or stack trace? I don't know what you call it in Node.js, but is anyone here familiar with it at all? I'm asking so if I know I should show something like that quickly. Anyone hear me? Hello, can anyone hear me?
Yes, you can hear you.
Okay. So should I take that as a no? So I'd like a response here, please. Should I should
Yeah,
I
Candy,
take
on your unmute your mic.
sorry?
Okay, yes, we can hear you. We can hear you.
Yeah, so I was asking if we are familiar with what we call the call stack. And if not, if I should show us or move along.
Please unmute your mic and answer the question. If you're familiar with the word stack, let us know. It's an interactive session.
Can you please show us?
Okay. Um all right. 1 minute. Um, okay. Let me just create a new file quickly. This is a typical HTML CSS stuff. So I'll try my best to use what's it called, JavaScript function calculates total. Let's see one to or should I just do this on a public website instead? Or anything? I think uh 1 minute. Um, okay, so let me just use an existing application. Um, uh, all right, so I will open a file quickly. So what can I open? Okay, so what's service? Oh, interesting. Yep, down the road. 1 minute, please. Let me just do this. Mm, okay, so um, consent stage was this return total. So at the beginning, I'm going to just call function, sorry, calculate total. Um, so okay, let me change the index to start. All right, so I'm intentionally doing two functions. So I'm going to, in my browser, this is the file, right? This is the stack. So I'm going to put the breakpoint here in the Chrome browser. I'm using Chrome. And once I refresh the page, because it's automatically calling it, so the breakpoint has been hit now. So yeah, remember we're talking about backtracking, right? So we're assuming that the problem is from this line of code. So I've set my breakpoints here. The call stack will easily help you trace back the things that will call. So on the right panel, on the right side, if you can't see this, I think you need to click on this. Okay, can't hide it, but if you can't see it on your end, you need to click on this to expand it on Chrome. Anyways, this is the call stack. So you can see on the call stack here, you can see this blue arrow. It's currently telling us that the file stack.js column 15, that's line number 15, which corresponds to this. So that's our current line. So subsequently, every other function that called each other down the line will be listed under it. So this next guy here is telling us that this the function above was coming from inside this function called calculate total at line 8, start.js line 8. So you can see it was here. You can see line 8. So if I double click on it now, I'll be taken there, right? So because it's just 2 in this instance, it's quite of it's simple and straightforward, but it's very useful if you have a lot of files talking and communicating with each other and you don't know exactly what file is calling what. So this is very handy in tracing your steps backward. Yeah, basically, so this is what I mean by call stack. Call stack is virtually available in all programming languages. In .NET, you usually see it in your IDE itself. That's Visual Studio or VS Code. I think in Java, actually not familiar with Java, but I'm sure everybody has call stack, because if your error is thrown, okay, let's do this. Let me continue this. Let me remove my breakpoint. So let's do the error. This function is not implemented. And save this. So if I go to my console and I refresh, you can see. So this is also referred to as your stack, the call stack. When you see at, so it's telling you that this error was thrown on this line at calculate percentage in this file and in this line number and in this column. So if I click on this now, it's going to take me there. You can see. So all of these things are useful when you are debugging. Okay, so let's move on quickly. Moving on. Yeah, so basically that's backtracking. The image here assumes that S is the beginning of the problem. Then you go via M1. Was it the issue? If not, you go in depth again. And if not, if you're sure, point of no getting feasible solution, then you return at this point. You check the next possible route and start tracing it backward. But this is in case you were not using a call stack. Do you get? Sorry. This is in case you are not using a call stack, because if in my example, I can see that I am calling this function twice here, which in turn will call this guy twice here. So, okay, let me do something that will better illustrate this example. So I'll put a if here. So I'll say if num1 equal let's say undefined, right? So it should throw this function. The number is undefined, right? So let's do this. I'll first call a valid guy first, and then second I'll do calculate total undefined space 200. So this should throw an error, right? So let me save this. So if I go to my console and I refresh, so I am calling this guy 3 times, but I can't tell exactly, let's assume I can't tell exactly which guy is throwing the error. So the typical backtracking approach will require that I set breakpoints for each of these instances. So I will check this guy, follow it through here, then go back, check for the second one, and then potentially for the third one, right? So which may not be productive if you have many entry points for your function. But if I set a breakpoint, where's my breakpoint? If I set a breakpoint here where the error is occurring, and then I refresh, I can easily trace it back, and I can know that it was when percentage was 10, and can trace your way back. Okay, so that's pretty one of the most resourceful method I personally use. So the last but not the least, cost elimination is very similar to backtracking, but it involves you eliminating some potential issues first. So you create a list of potential cause. What may cause this error? Is it that I have a wrong input? Is it that the function is not called early enough? Then you list it out, then you start testing for each scenario, right? So, and then that will help you figure out what went wrong and when it went wrong. All right, so I think this is the last phase, if not the least. So techniques, the common techniques that can be used to help you debug faster. So let's get right into it. Okay, so there is what we call debug cycle. Again, I apologize, I'm unable to really showcase this in a practical way. But I hope as you continue in this your dev journey, you'll be able to, remember some of these things. So quick debug cycle is basically, it says it is when, let me just read this. It is critical to try and make the time between the relaunch and the critical point as fast as possible. So because the example I've been using earlier in the code is basically one HTML file and one JavaScript file. So I'm just refreshing to get to my point of error. So imagine you have an Angular project, or let's say a Node.js project, a backend project, and the error, and you have a flow whereby when a user uploads an image, you have a system that automatically optimize that image, like reduce the resolution so that the size is not too large for you to store in your storage. So after reducing it, then you also have a flow to what's it called now? To create a thumbnail out of that image so that you can show thumbnails when they load it at first. You know, the thing all the social media does, that until you now click it, it's not load the actual image, which is usually of a higher size and resolution. So that's three phases. First, you downsize the image. Second, you separate it, you create a thumbnail. Then you save both the thumbnail and the image to your data, to your storage. Then you return a success state. So imagine something is failing in that flow, and all the user is getting is, sorry, you're unable to upload your image at this time, and you want to debug. And the interface to upload that image is, let's take, what's it called? What's the name of this social media app? Instagram, for an example. So the mobile app, and for you to recreate a problem, imagine you need to log in first. You need to now navigate to the interface that you used to upload the file. Then you need to select the file and then upload. If that problem is hard to find, that process alone can be very tiring just to recreate the problem. So quick debug cycle says you should find a way to initiate or to reproduce that problem quickly from when you start the application, from when you run the application. So I think in C#, I'm not very familiar with Node.js. We have something they call constructors, which is usually the first method that is automatically called in every file. So constructors are a very good place to put functions that you're trying to debug. As you can see here, it's for the purpose of debugging alone. Always remember to remove unwanted code. So constructors, maybe the entry file. In Angular, we have main.ts. This, so we can put code snippets there to try and reproduce the error as soon as we can, so that the debug cycle alone will not weary you down. Next thing, small payloads. Shrink the amount of data to work with to small or tiny data. This helps you, this also contributes to the quick debug cycle. So imagine trying to debug the problem scenario we have of uploading images. So uploading image to your, let's say you're using Azure data storage or AWS storage, and you want to debug a problem like that. And every time you're trying to debug, you are uploading an image of 20 megabytes. I mean, even if your internet is fast, it's going to weary you down quickly once you have to do that over and over again. So small payloads just says find something that is smaller. So it may not be a file, it can be an array, like the initial example I showed in the C# code. Instead of testing with an array of 500 data points, test with 3 or 4. Especially when it comes to array, it can help you even mentally remember or compare the values. So you can personally do mental health that at the first iteration, I expected this number, then at the second. So imagine it's 500 numbers or 500 characters. It's going to take a while. Then next, real data versus random data. So you need to know when to use either of those. So the key factor I use personally is if the program keeps crashing, then it is not likely to be a data issue. Like anytime I run it, if it keeps crashing, I really don't care about the data now. I care about making it work at first. Though if it is crashing intermittently, like it works now, it's not working after 1 hour, it's not working when you do something unique, then that is data, that is a specific or real data scenario. So if you can make this decision, it will help you also speed up your debugging process. So you can identify when you don't need the real data, you don't need to actually sit and construct real data to fit the system needs. We can just always pass random data to sort the issue, right? Okay, moving on. Okay, last slide but not the least, async and sync mode. Remember when we were talking about, what's it called now? The common reasons cause of bugs when your application is dealing with concurrent operations. So that's when it's running asynchronous operations, right? So you need to understand some of the factors surrounding what you are currently debugging. So a not rule of thumb, but I've come to realize that asynchronous operations are usually difficult to handle compared to synchronous, right? So but okay, when an exception is thrown during an async operation, the program is not likely going to tell you where the problem originated from. So this also from my experience, because async operations are usually handled, I don't want to use the word background, but the system basically finds a way to free your process to allow other things to go. So it doesn't really keep track of the data that or what exactly is happening within that operation. All it does is initiates the operation. Then when it is done, it will return the result back to where it was initiated from. So the actual operation that is doing, your program may not keep track. So that's why asynchronous stuff are usually difficult to debug. That is where your call stack or call stack is also what I meant by stack trace here. Is your best ally because your call stack will usually tell you, give you this information, right? So some of the times in that case, you're usually bloated with a lot of information. Just need to be patient and look through it. All right, exception handling. Okay, so don't write bugs into your code in the first place. But most importantly, implement error handling and logging. No developer on earth can write a code, especially when there's a full-fledged feature or a full-fledged system, and boast that you wrote everything once and ran once, except God. Anyways, so as much as you're trying to avoid doing things that can be buggy, also implement error handling. Always implement error handling. Don't allow your users to see jargon, because your code will give you jargon. So error handling is usually something global within your system that will handle any unhandled error, any error that you could not have foreseen. So it's going to catch it, store it, log it, or do anything that you've told it to do, and then give a user-friendly error to the user, like a user-friendly message. So again, looking at our example, let's say it was during the uploading to your storage that something was failing and your AWS is returning a lot of jargon that sometimes it might not be jargon, it might be data that you don't want it to be exposed. Can be giving you an error that saying, let's say your so AWS, and it will write the URL is not correct. So if that such data leaks to the public, there's a potential for even attackers to exploit your system. So always implement error handlers and logging to log your data or to log your errors rather. Okay, so last but not the least, if I must dare say the actual most important thing, take breaks. Take breaks when you are trying to fix an issue, when you are trying to find solutions, take breaks. The debugging process can be very mentally taxing. It takes a lot of mental processing power. That's why you do not find a lot of people in backend development. We are not trying to say people are lazy, but it just requires a lot of brain power, usually when you're working with backend systems, because before you know it, you are thinking about a lot of things. You're thinking security, you're thinking performance, you're thinking efficiency, you're thinking a lot of things. So always take breaks. Don't beat yourself up if you're unable to fix issues. Reach out to people, reach out for help, and ask your peers or seniors. Stack Overflow is the decade. It has been around for decades, helping developers and all that. And then I was surprised one day when I was searching for a fix to a bug, and the solution for it, I saw it in a Stack Overflow answer that was given 9 years ago to the time I was doing that. I think that was 2 years ago. So I was trying to search for that solution. So someone wrote that solution there 9 years ago. Now that will be 11 years ago. I mean, and it's still relevant. So please always reach out, do research. Don't always box yourself. Take break, take a walk, listen to music. Just give your brain rest and allow yourself to cook, right? So that is very important. So this brings me to the end of this simple debugging talk. So I know there's a lot of jargon, but I hope I've been able to share one or two information that will help your programming career. Thank you. So do we have any questions? I would appreciate questions. It might be around debugging, it might not be, it might be direct questions about code. So please feel free, fire away. I'll try my best to answer.
Thank you so much for that wonderful presentation, Mr. Mordecai Godwin. So, guys, please ask your question. Ask questions related to what he has taught us, what we've learned today, or questions not related but tech related. Lindway, Adibowali, Markin, Temitope.
Hi, how are you? I just wanted to say thank you for the presentation. It was a very lovely one because it's something that we normally come across everyday errors and stuff, and it tends to be very demotivating sometimes. So, for interest sake, I just wanted to know, like, what was your first project when you started your tech journey, and then also in terms of personal experience, would you say like the tech industry is it kind to newbies? Or do they just let you swim with them, just throw in the sea and then you swim with the big sharks? Like, what would you give a newbie like advice, Jay? I just wanted to ask you, just in terms of your own personal experience.
All right. Thank you. That's an interesting question. It made me realize just now I didn't even say anything about my background and all of that. Okay, so like I mentioned, um, I'm full stack engineer or major in backend. I've been doing this professionally, like my first job after internship for 5 years now. So I'm also still pretty young. But so what I would say to um, freshers when you say that is please be open, always ask questions. For someone like me, not like me, for me, my beginning was not very pleasant, and that's because I still think I am a very shy person. So I really didn't like asking questions. I just liked thinking. I liked, pondering on things, trying to find out how things work myself. So although you tend to learn a lot from that process, but at the same time, you also tend to waste time. So I'm also a self-taught developer, although I did computer science in school, but then we were not really taught we are not really given the knowledge that is required in the industry. They just touch base, introductory class everywhere. So I, 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 I was doing a lot myself. I was trying to figure out everything myself. I remember downloading the entire .NET documentation. I mean, a 5,000 page document, PDF, and I was reading it like myself. I was feeling, yeah, I can do this. I mean, I got to, I think, page 2000. I was tired. So I didn't finish. The same thing for this textbook, O'Reilly O'Reilly. I don't know if anybody's familiar with that. That's that author. They've created books in different languages. I read that too. I did not finish, right? So first advice, be open, ask questions, collaborate, right? You can only be wrong maybe once or twice, right? So and it won't take anything from you. It will help you learn faster. And that another thing I would say, which is very important here. Um uh okay, how would I say this that it will land very well? Okay. Do not always, yeah, the keyword here is always. Do not always do la copy la paste. So don't always copy and paste code everywhere you find. When I say copy and paste, now I'm talking of a full feature. For example, I want to create a product, an e-commerce application. I want to maybe buy a template or get a template. That one is fine for WordPress developers. But if you want to do actual coding, you need to know exactly what's going on inside. Is either you get the working code and intentionally break it. I don't know if you got that. If you get a working code base, maybe from a template or from an existing project someone else did that you did not do, and it's not something you know how to do, don't just take it and use it and forget about the day. If you really want to learn, check the code, comment out the line, remove one line, add your own line, see what happens, set breakpoints, go through it so that you understand the code. Because what that will do will help you understand things from a broader perspective. You've already seen the output, now you can understand the process. The flip side to that is you pick it from scratch yourself. As you are doing it, you fail, you ask questions, you collaborate, you fail, you ask questions, you collaborate. That is what you build your learning blocks. That is what has helped my debugging abilities to date. This is not to brag, but I can say in the company where I work, uh, people prefer to give me issues than to give me features. So I don't know if you understand that. because when it comes to problems, I know how to find it. I may not know the solution, I may not know the code at all, but when it comes to problems, I know how to Google search. Another thing is Google searching is actually a skill. The more you do it, the more you get better at it. So there is one day, let me share a scenario at work. I think that was also when I just got to ask someone that I was trying to find a solution to something. I had spent almost 2 days trying to find it. So because of time and deadline, I reached out to my boss, my team lead. I was like, I have this issue, I cannot find the problem, the solution to it. And he said, okay, that's all he said. And just about 20 minutes later, he just sent me a Stack Overflow link to go and check. And I checked it. The same Stack Overflow that I've been foraging, the same Google that I've been using, this man punched in a keyword once and got the solution. So I had to go back to him. Bro, please, what exactly did you type in your Google search? I really need it. So he sent it to me. So that's when I knew that this thing can be a skill. So you can also learn online how to refine your search to find solutions. So basically, what I'm just trying to say is don't just take the finished product out of the box and use. If it's a fix to a small problem, like a small problem in your code, that's fine. It's fine to copy code to sort it. But if it's an entire feature, don't just do copy and paste and move on with life. You need to understand what exactly is going on there because that's how you learn, right? What else? Talked about collaborating, speaking of. Yeah, I think that is another thing. Yeah, I would say. Okay, I think is try and know the terminologies for some of these things, especially when you don't have a science background. If you are coming from different industries, let's say the art industry, or something else that's other than science or computer science, try and take your time to understand or to know, just knowledge, to know some of these terminologies. I'll share an experience with you. Actually, the place I'm currently working at, when I was doing the interview, I was asked a question, and the question was simple. The question was, what do you know about dependency injection? Before I got to Axamansad, I've had over 2 years of experience, and I've been using dependency injection all my entire career before then. But guess what? I could not answer the question. I did not know. It was as if I've never heard of that phrase before in coding. So I was stammering. I had to just tell them. I just said, I don't think I know what you're talking about. So I can't answer that. And that's all. So, but I eventually got the job, right? And I remember asking the guy that interviewed me after I entered, I think 1 year later, that I really want to ask his opinion about my how did I do during my interview. He said I did not do well at all. There were 3 people on the panel that day. He said 2 people declined me, so just one. I said, let's give this guy a chance. And I asked him, how about now? What do you say? And I said, yeah, good. So we smiled and laughed about it. But long story short, not knowing the technologies will have cost me that job, even though I can do it. So it's like saying you can drive a car, but you don't know what the car is called. Sounds ridiculous because all of us know what cars is here. But then that's how it sounded ridiculous to them when I did not know how to define something as simple as dependency injection for the level of experience I was claiming. So, anyways, this also happens a lot for self-taught developers like me. We tend to just focus on the doings. I like to call it doings, but then also try as much as possible to look at the terminologies, the industry terms used for some of these things. All right. I hope I've been able to give 1 or 2 points. Um, thank you. Hi, Adebowale. You answer.
Thank you very much for the insightful topic on debugging. So, my humble question goes thus: in backend development, do you usually get people who have done the design of the different endpoints, or you are the one who's going to decide it? I'm just asking this for industrial standards. Then the second aspect, is it possible that through the design from whoever is designing it, you could already have issues from that point due to the design? Because I know that most times you just get what do you call it, UML and the likes of it, and then you're expected to develop codes from them and the likes of it. I don't know how it works out where you work presently, but maybe you can just throw insight into that aspect. Do you get a design from somebody, or you are the one who do the design and then give your endpoints to the front end guys who needs to ingest them and the likes of it? So for industry standard, just give us an insight into it.
Okay, that's a very good question. Well, like you said, industry standard differs. I hate to be the one saying this, but like I said earlier, Nigeria in the Nigerian industry, there's a lot of things that are still not done. So I'm saying this first so that when I say what I think is the industry standard, and you do not get it in your first official rule, don't run away, because most Nigerian companies don't follow industry standard. Let me boast above you. Sometimes you will not even get any form of design. All you get is requirements. You want to achieve this, you want to achieve that, go and cook it. And it's your responsibility to cook it and bring the finished product. So, but in the industry, the proper flow first is you do a requirement gathering, first understand what we need to do. You gather it, write them down, then okay, so it can also depend on the person. So there are some roles where if you are the senior developer, that means you are the one that will come up with the designs in the first place. You are the one that will structure the system. You design the architecture, you design the UMLs, you design the data flows, you note the data that will be captured and all of that. You are the one that will do it at the end of the day. But if you're not in that position, that means someone else will do it, and then you follow that structure to build what you need to build, right? So sometimes some companies like to bring UI UX before the backend. So that helps us to fine-tune the actual data we are working with, because basically most of what the backend is doing is capturing data, storing data, and manipulating data. That's the summary. So we can be saying, okay, we want to create an AI system that will say, let's say, we'll be generating or suggesting hotel reservations to people that are looking to travel or people that book flights. So you should suggest hotel reservations. That is the big requirement. Sorry, that is the overview of the requirements, right? It's possible for a backend engineer to go with that information and structure something, design something, and start writing code. But it is usually easier when the UI UX has done something first, like has created the interfaces and presented it. What that will do, the UI UX will use the actual data point that will be captured. Are we taking first name? Are we taking last name? Are we collecting email? Are we collecting what's it called? Are we collecting payment details? Are we retrieving their fingerprint? All of those details usually is not sometimes can be overlooked by a core backend engineer. But when a UI UX person has fleshed it out, it's usually easier to pick up, and design and start coding. And in some other companies, as far as my knowledge, by the way, I've not been to all of these companies I'm talking about. I have friends, right? We talk about these things. So in some other companies, they run them concurrently. The only thing they do together is the requirement gathering and the project specifications. After that, the UI UX is doing the stuff. The backend guy started his own designs and all of that. So yeah, the structure, basically you design your backend system first before you start coding, using the information you have from the requirement gathering, basically. But then for extra fine-tuning, a ready UI UX will help you in the long run because you can directly see the information that you need to capture and send to the front end. If there was no UI UX, so let's say, for example, you collected first name and last name and email, but then after the UI was done, they needed to include middle name. That means you need to revisit your endpoint and provide middle name. Front end guy needs to also revisit the endpoint. That's it. Okay, well, front end will not have started yet. So basically, for you as a backend dev, UI UX coming after you've designed your own system may require you to revisit that design. I don't know if I've been able to answer your question. I don't know. All right, thank you. Okay, do we have any other question or addition? Actually, I'm also here to learn, so I appreciate one or two information. Okay, hi, Adebola, please go ahead.
Okay, just one last one. So knowing fully well that for development and vulnerability, and then as well as hackers in present day application development, most times, how do they manage issues like, how do I say, not manage, how is this inculcated into development itself? Knowing fully well that you as a coder, you feel you've done all that you need to do, but back there, somebody can just download all you have on your back endpoints and then be able to know how they can come in. Is there any way, most times, your company, let me use your company for an example, put all those into considerations when you are doing your development? Or is there a set down security principle to adhere to while you are doing your development, as far as whatever the nitty-gritty of security is concerned?
Okay, good question. So for us, actually, it applies everywhere. There are some basic things you just need to do, right? As a start, there are basic requirements. For example, authentication and authorization. So authentication is the access to the endpoint in the first instance. So let's say the logging in and logging out. So the user logs in, so you verify that that user is in the system and can use your system, right? Then the next level is authorization. So authorization is who then has the authority to access what. So, like in a typical company building, physical building right now, not all okay, let me use a restaurant, for example. You see some signs that will say staff only. So even though everybody is allowed within the premises of that building, not everybody has the authority to enter into some doors. So that is authorization. So after people have access to application, then you need to control what exactly they can access within the system. So for example, some people can be an admin, they can access everything. Some other people can access just their own information. Even for some admins in some systems, you can also see just your own information. There are some data you'll not be able to see and all of that. So that is some basic things you need to put in place. And another thing you should always also keep note of is forgetting the abbreviation now. It has to do with personal. See what I'm talking about, knowing the terminology. So I'm also still learning these things. Although I do it every day, I can't remember the term now. So it has to do with personal, how you handle personal information. So you also need to be conversant with the laws of the country that your system is running in. So for example, in Nigeria, there's some data that the government does prohibit you from retaining. So you can use them to process the user, but you must not store them in your database. So users like their fingerprint information, their BVN data, if your site takes payments, their CVV card details, you must not store it in your database. So some of these things contribute to security. So even though your system is compromised, your hackers do not get access to data they're not supposed to get access to. Another very important aspect that we just started dealing with recently is communication between the front end and back end. So now we encrypt our data, right? We encrypt every data that the front end sends to the back end is encrypted. So you cannot just go to the network tab and see what exactly was sent. You cannot, and even if you sent it the way it should have been, the backend will not be able to decrypt it and will not be able to provide you access. So basically encrypting the data that you are sending to and fro. I know that we sometimes we say once we've provisioned our URL on a secured protocol, that's HTTPS, having the S layer. Well, that does not stop a lot of hackers or the good ones anyways. So that's why you need to take your own security to your own ends. So encrypt your payloads, your data that you send to and fro front end and back end, so that the individual application can decrypt it by themselves using the appropriate key. So you can study that on your own. Another measure you put in place is when it comes to security. Okay, yeah, there are some you need to study in depth on some of these things, but there are some headers, headers that you need to build in your system when you are coding. So headers like X scripts, what's it called? Forgotten. I can send a link. I can show a link later that has, or I think there's an article on Medium that talks about it. So these headers, when you put them in your application, it will help. It will curb against bots like robots, tech bots that people use to crawl websites to automate things. So it can help you fight against that. It can also help you fight against something we call cross-site scripting. Can also help you fight against some other known vulnerabilities, right? Another measure we put in place while we build projects, while we code, is our communication between the backend system now and the database. So especially if you are using relational databases like SQL Server, there is tons of history of people hacking systems via the queries that they use to query the database. So you need to they call it SQL injection. So where they inject some funny characters from the front end and to go all the way to disrupt the system in the database. So you also need to be careful of that. You find a way to cope that. So there are tools to help you with some of these things. Another very key factor is also something we call rate limiting. So rate limiting is when you limit the rate at which your API can be called in a time frame. So for example, I can say you can't call my API more than 10 times within 1 minute. So this is very, very and extremely useful for potential hackers that can write code to automatically be calling your API, because at the end of the day, they will end up consuming your API resources, your RAM and disk space, and it will incur more costs, right? So you need to set up something we call rate limiting. So it's usually simple to do. So it will limit how many times someone from a specific IP address can call your endpoint within a time frame. So you can set it within 1 hour, you don't want it to be called more than 100 times. Within 2 hours, you don't want it to be called more than 30 times, and all of that. This rate limiting is also useful beyond security now for applications that serve multi-tenants. So for example, let's say B2B. B2B is business to business. We have B2C, business to customers or business to clients directly. So for example, Facebook is B2C. Every user is the direct customers. But Paystack is a B2B company. So Paystack service businesses. So other businesses use Paystack to conduct their own business. So businesses is the main customers of Paystack. So you get. So rate limiting is also useful to control how your clients access your your own API. So, for example, imagine one of the business that is using Paystack is compromised, and they are hitting their own endpoint 100 or 200 times per minute, which is also calling Paystack. So, rate limiting on Paystack end is also going to curb that, so that the breach is not going to get to Paystack. So, um, truth is, as you go, you learn these things, you pick them up. So it's not something you know all at once. So just take it a step at a time, a step at a time. For at this stage that I just starting, you don't have to know all of these things. You can play with it, you can do it once, but don't focus on it. Focus on getting enough knowledge about how the system work at large, how to provide solutions. Then you cannot take it to the next layer, providing security and increasing your security and all of that. Yeah, so those are some of the few things that we do to secure our systems, or that I do to secure my systems.
Thank you very much. This is so insightful. I'm grateful. Thank you.
Welcome, thank you too. All right, do you have any other question or contribution?
Thank you so much, Mr. Mordecai Godwin. It's been insightful, and we've learned a lot today. Guys, hi guys. Please confirm you can hear me. Please reactions for Mr. Mordecai Godwin. If you enjoyed the session, awesome. Um, in addition to what Mr. Godwin has said, like the terminologies is one of the most important things. So he was mentioning UI UX. I don't know if we all know what UI UX means. Most people call them the product designer. Most people call them UI UX. UI UX is basically user interface and then UI experience. So in the context he which he was explaining, he said that and most company does it in the way that the product designer or the UI UX gets to design the whole interface, then presenting it to the customer or the client. They make all necessary adjustments, prototype, and all. Once the front end is ready, then the back end studies it and then know like, okay, this and this is what information is needed or whatever. So it goes on and creates endpoints and the likes, then integrating both of them together. Yeah, so terminologies is one of the important thing, and also we've learned about the art of the art of debugging and types of debugging. And then he also shared insights, personal experience, and how he was able to learn the issues he had and how he was able to overcome them. So, like I've always said, Dive Africa is a community. The community is a space for you to grow, connect, collaborate, ask questions, share your progress. Like he said that have he had an issue and he has searched and searched online. He was unable to get the answer, but he was able to ask his colleague and he got the answer. So try as much as possible. I'm also a shy person. However, in this tech community or this tech space, you need to connect with one another. So that it helps growth. So lastly, about the Adibawale asked about the security question. So backend is like the brain of like of an application. You do the whole data manipulation, just like we've been doing in our class, being able to use the delete, update, put different method, and we're learning about the status code and all. So um, um, Okay, yeah. So basically, thank you so much, Mr. Mordecai, for that wonderful session. It's really great to have you on this call. We appreciate. Okay, so any other question? Any other addition? Lindway Adibawali Marking. So this session will be recorded and then will be dropped on the channel. So Mr. Mordecai has dropped his LinkedIn name and also LinkedIn link as well to an email address for those of us that would like to connect with him. So kindly take a screenshot or copy and search and connect with him. Thank you so much, Mr. Mordecai. Thank you guys for joining. So I've come to the end of the session. Uh, I would say that we usually have a lot of people joining this call, but I'm getting messages from a couple of persons due to one or two reasons. That's why. However, they would watch the recorded session. So thank you so much once again, Mr. Mordecai. Um, we hope to bring you on board again to learn
Thank you.
more from you.
All right, thank you. It's an honor to be here. So, yeah, like someone did said, sorry, yeah, please feel free to reach out via email or LinkedIn. I'm more than happy enough to assist in any way or any question that you may have. Yeah, do you have a beautiful night? Um,